So what is an arithmetic sequence? So an arithmetic sequence is just a particular type of sequence where you get the next term by adding the same value each time. And what we do is we call this the common difference. Common difference. And we represent that with just the variable d. Okay, and this is going to be important in our equations, which we'll get to in just a second. So if we're looking at this first sequence here, to get from 3 to 8, we would just add 5. So 8 minus 3 is 5. 13 minus 8 is 5. 18 minus 13, 5. And 23 minus 18 is 5. So the common difference is 5, which makes this an arithmetic sequence. Okay, let's look at the next one. So 52 minus 64, that's negative 12. Same thing here. Negative 12, 28 minus 40, negative 12, 16 minus 28 is negative 12. So to get to the next term, I am subtracting 12. And again, this would be arithmetic. And then the last one, I know fractions aren't everyone's favorite, but let's first just get a common denominator. So I'm going to multiply the numerator and denominator by 3 in this case. So I would get 3 over 6, 5/6, 7/6, and then 9/6. And then we can see pretty quickly that 5/6 minus 3/6 would be 2/6. Same thing here, same thing here. So my common difference would be 2/6, which we can reduce to just 1/3. And again, this is an example of an arithmetic sequence. So let's look into the general formula for an arithmetic sequence. An arithmetic sequence always can be written in this form where u sub n equals the first term plus d times n minus 1, and again, d is the common difference. But before we practice that, I want to make sure we understand where that comes from. So let's take a look at this sequence right here. So I already broke this apart and put this in the table where my first term is 3 and second term is 7 and so forth. But let's see what's actually going on here. So to get from 3 to 7, to find my common difference, it would be 7 minus 3 is 4. And if we check that out, 7 plus 4 is 11, 11 plus 4 is 15, and so forth. So that does work. So if I want to expand this out using my common difference, my first term is just 3. I'm not adding 4 yet. But to get to my second term, I took my first term, which was 3, and I added 4 to it. To get my third term of 11, I took my second term, which I just wrote as 3 plus 4, and added another 4 to it. And we did this in the previous video, but if you didn't watch that or you need another example, that's what we're doing right now. So 15 was the previous term plus another 4. 19 was the previous term plus yet another 4. So to get any term, I know that I'm adding a bunch of 4s on here indefinitely, okay? So let's make this a little bit neater. So the way I can express this then, my first term, I'm adding 0 4s, right? So technically I could write it as 4 times 0. I'm not adding any. For my second term, I'm adding 1 4. My third term, I'm adding, 2 4s. My fourth term is getting 3 4s. My fifth term is getting 4 4s. So if I want to express this, u sub n, I know I'm adding amount of 4s, and that amount of 4s is 1 less than whatever n is. So I'm going to write that as n minus 1. So that's where this equation comes from. If we just use the equation, we would have un equals u1, my first term, which is 3, plus my common difference, which we found is 4, times n minus 1, which is exactly what we got down here. All right, so let's go through a couple of examples of arithmetic sequences. I would definitely encourage you to try these on your own first, so if you need to pause it and try it and then watch, that would be awesome. Okay, so for this first one, for the arithmetic sequence here, write down the value of u sub 13. So if we go back to the previous slide, our equation for an arithmetic sequence is un is equal to u1 plus d times n minus 1. So all we need to fill this in is we need the first term and we need the common difference, which are pretty easy to get. So the first term is right here as 18, and the common difference, write that down, 18. And my common difference we find by subtracting the second term minus the first term. So 14 minus 18 is negative 4. If we find those two things, it's literally just plugging in. So un would be 18. Instead of plus d, it's negative, so minus 4 times n minus 1. And that is it. Now to find u sub 13, we're just plugging in 13 now. So u13 would be 18 minus 4, 13 minus 1. Let's carry it over here. u13 would be 18 minus 4 times 12. So that would be 18 minus 48, which would give us negative 30. So my 13th term is equal to 30. All right, so in this one, given an arithmetic sequence in which u1 is negative 10 and d is 5, we're trying to find the value of n such that u sub n is 125. So they automatically give us our first term and our common difference, which is awesome because that is the two things we need for our sequence. So we have u sub n equals my first term plus 5 times n minus 1. Okay, so what they want us to do though is find the value of n such that u sub n equals 125. So it's kind of the opposite of what we did in the previous example. They're giving us this value to substitute in so that we can find what term that corresponds with. So all this takes is a little bit of equation work and then we're good to go. So we're going to add 10 to both sides to get 135. Divide both sides by 5, which gives us 27. And then just add our 1. So n is equal to 28. So my 28th term would have given me a value of 125. Next example. So finding the number of terms in the finite arithmetic sequence, negative 9 all the way up to 35. So we're finding the number of terms. So we're finding n in this sequence. And if this is my first term, second term, third term, 35 is going to be my last term, so that's going to be the one that is key, okay? So let's go ahead and first just fill out our general form. So un equals, u1 is negative 9, first term, and then my common difference is going to be negative 5 minus negative 9, which is just 4, so plus 4 times n minus 1. When it's asking for the number of terms, it's really asking for, okay, the number of terms is going to be based on whatever the last term is. So if my last term is 35, we want to figure out which term this actually is. So it's similar to the last one. So we're going to solve for n. Let's go ahead and do that. We're going to add 9, get 44, divide by 4. Is 11, so then we get n equals 12. So there would be 12 total terms in this sequence. All right, last one, and this one is pretty tricky, so we've got to think about it a bit. So we have two terms of the arithmetic sequence, u5 and u10. We're missing u1, and it's not super easy to find the common difference, so this one's going to take some thinking. So I'm first just going to kind of leave spaces. So here would be u1, u2, 3, 4, 5, which I have. Here's my u5, 6, 7, 8, 9, and 10, which I have. Okay, so let's think about what we know about arithmetic sequences. So to get to the next term, I know I'm adding some value, so I'm going to just call that x. And I would be adding that same value each time, right? See where I'm going with this? So if I want to get from numbers I know 7, and I know I get to 37, and I know exactly how many spaces it takes me to get there. So I can use this information to make an equation to find what this common difference is. So I know I have 7 plus 1, 2, 3, 4, 5 x's. And when I do that, it's going to get me to my value of 37. And this easy peasy to solve. So let's subtract 7, and we get 30. Divide by 5, and we get 6. So we just figured out our common difference is 6. Okay, so check 1. Off our list, we have our common difference. Now we just need our first term to be able to write our formula. So to get our first term, we kind of just want to work backwards from here to get back to our first term. So if I'm adding 6 to go up, I would just be subtracting 6 to go backwards. So 7 minus 6 is 1. This would then be -5, -11, -17. So -17 would be my first term. And now that we have what we need, the last part should be easy to put it together. So u sub n would be my first term, which we found to be -17, plus my common difference times n minus 1. That's it. In this video, you learned the definition of an arithmetic sequence, the general form of an arithmetic sequence with our first term and our common difference, and then how to solve problems with arithmetic sequences. Thanks for watching.